Okay. So this is going to be a bit of a hybrid um, bit section. I'm going to briefly lecture with slides, and then we're going to dive in and look at some stuff in Xcode. Okay. So documentation. You'll note that there's kind of been a consistent theme for today, right? Which is less about writing code and more about how do we comport ourselves while we write code. I call this professionalism. Okay. What it means to be a professional who writes code. And included with professionalism is proper documentation. So, when you are writing your code, you will want to set up correct documentation for your code. Now, when people hear documentation for code, there's this kind of like this almost dread settles in your shoulders where you're like, oh gosh, I'm gonna have to go write a document. I have to find a wiki somewhere. I have to fill it out with stuff. I just want to write code. I want to write things and I want to make the computer do stuff. I don't want to tell someone else how I did that, right? And that's fair. That's fair. But think about it this way. You build an app, you release the app, you send it out into the world, the whole wide world, and you kind of stop working on it for a little bit. You start going, you do something else. Maybe you get hired by some company. It's continuously running in the background, earning you a little bit of tiny little bit of passive income that's barely, it's barely paying for your Apple developer account already. But like, whatever, it's fine, it's good, right? You're happy with it. You're glad it exists. Uh, 4 years pass, and now it's on an its minimum iOS version target, is about to be deprecated, and your app will disappear and fall off of the App Store if you don't go back and update and change it. You haven't really looked at it in a long time. It was your first app. You were glad it was there and glad it existed, but you didn't super care about it. You'd moved on to bigger and better things, right? So 4 years later, you go back and you're like, okay, I'll just update the minimum version. So you do, you update to the newest minimum version. And when you do that, you realize that, oh, you're jumping four major versions. There was a bunch of code you used that became deprecated along the way and then was disabled in the latest version. Now, you could target one of the versions where it was just deprecated and not removed, but you know that that means that you're going to have to come back in 2 or 3 years and do this all over again. And you'd rather come back in 4 years and do this all over again, right? Or maybe you decide, hey, you know what? This app actually had a lot of potential. I forgot that I did all this cool stuff. Let me go in and make it modern and new and apply all the things I've learned and make it awesome. And then it'll go viral and I'll be rich and a millionaire and it's great. None of that will happen, but it'll feel nice to think about, right? So you go in and you make the change. Your code won't compile because you're on the new minimum target version, and so you think, oh gosh, okay, I got to go in and I got to get on the new libraries and everything. I got to change everything. And you go in and you look at this code and you're like, who the fuck wrote this? What idiot? Who who did I let in my code base? Because this was written by some mouth breather, right? You of course look at the git blame and you see it's only ever been you writing all of the code, and then you feel bad about yourself a little bit for a little bit, and then you're like, no, 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 I'm better now. I've learned. It's been 4 years. I am much more of a improved programmer than I once was. I can do this. So you dive in and you try and figure out what's going on and how to fix the problems, and you find that you're really struggling to understand why you did things the way you did. 4 years later, it can be very, very difficult to remember why you made all those tiny little micro decisions we make when we're building and programming something, right? Um, so you go in and you're like, oh, this makes no sense. This is just an idiotic way of doing it. I'm going to change this. And you change it. It's doing something else now. And you fix the problems, you fix the bugs. But while you're there, you also, quote unquote, make it nicer, right? You improve it, okay? In addition to making sure that it runs on the new minimum version that you've set, you also add functionality, right? And in your mind, all you've done is add functionality, right? You've just added new things. You release it to the App Store and you dust your hands off and you're like, cool, I'll come back to this again in 4 more years, right? And then you notice you get a notification or something on your email, that your latest new version of your app, its rating is tanking, right? It's gone from like where it was sitting at a healthy 4.5. So that we're back, we're plugged in, it shouldn't happen again. That's what happened to the second recording. Unfortunately, it disappeared. It's gone forever, but that's okay. You all were here. So you get this notification. You're starting to see that people are complaining about your application. You know, you used to have 10 4.5 star ratings. Now you have 75 1-star ratings, right? Turns out when people really, really like an app, they don't rate it typically. But when they really, really dislike an app, boy, do they rate it. They love to hop on and give you 1 star. Okay. When people run into a problem, they like to complain. When things go really, really well for them, they don't really have much to say. That's a dichotomy that you'll have to get used to when you develop apps for the App Store. So you hop onto App Store Connect, you open up the ratings section, and you start to read the 1-star ratings and see, and some of the ratings are completely useless. They just say app don't work, no mo, and that's it, right? Some of them are really overly detailed and technical and act like they really understand the problem, and they're talking about like server-side nonsense that makes no sense because your app is completely local, so they have no idea what they're talking about, right? And then you'll get the occasional thing where someone will actually say something useful, where they'll say, oh, this app was great until the new version, when the functionality that I actually used it for, the widget that changes this file format to this file format, stopped working. It doesn't exist anymore. And you're like, what do you mean? What I didn't remove any functionality. I just added stuff, right? It turns out in the process of refactoring and fixing, getting yourself upgraded to the new version, and making your app better, you accidentally removed like a button to a screen that like had some functionality on it, right? That your users really, really liked, and it turned out that's actually the main reason people used your app, was that one piece of functionality that you forgot, right? One way that you can try and prevent yourself from running into this sort of problem is documentation, okay? Now, here's the thing. The absolute best documentation for your code is your code. It is always going to perfectly document itself, because as long as you can read it, you know what it's doing, assuming it's not too complicated. If it's very complicated, you might forget and not run, it'll be hard to figure out what it's doing. But the point being, ideally, you write code that is clear and obvious and can be read by a developer, such as yourself, 4 years later, and understood, and then you know what it does. But sometimes it can be nice to have a little bit more than that. And that's where documentation comes in. So to start with, documentation is never going to be perfect. It's never going to cover everything. Code should be enough, and documentation helps us fill in the gaps when code gets too complicated to easily and quickly parse, right? So what do we use documentation for? Okay, we've got 2 kinds of primary things that you will care about for documentation. And some of these we've kind of looked at before, but we'll look at them again from the context of documentation. So the first thing are diagrams, okay? Diagrams are a way for you to document information about your code that is visually appealing, easy to understand, and it doesn't involve reading a lot of text. Okay, it involves looking at something. So it depends. If you're like a very visual learner, you'll love diagrams. If you are not a visual learner, then you will not like diagrams. So it's to flavor. Okay, you don't have to use diagrams at all, but you can if you want. If you're working in an enterprise corporate environment, you should probably have some diagrams. They'll make it very easy to explain to your colleagues 3 teams over what your code does when they take ownership of it, because there was a coup at the SVP level and your organization got split into 3 pieces, okay? And then your package all of a sudden is being owned by a different team. It's good for you to have some diagrams so that they know what's going on in the code, all right? So, diagrams. Let's talk about it. I've got 3 kind of basic kinds of diagrams here, and then there's like variations upon these that are sort of hybrid versions. But these are kind of the 3 core types of diagrams you'll find in programming, okay? Obviously, there are other kinds of diagrams for other subjects. I know Don't show me a Gantt chart. I know what a Gantt chart is. We don't care about Gantt charts. We're doing development, not project planning. Project planning is a different class. Okay. So UML diagrams. I think we've seen these before or something like them when talking about, ORMs and stuff, but a UML diagram kind of thinks about and assumes that the world of programming breaks down entirely into types, right? You'll recall types are classes, structs, actors, enums, functions, right? Now, UML diagrams are more about classes specifically because they were created for Java. And in Java, there's primarily one kind of type, and it's classes. And also in Java, everything is a class, okay? That's not true in Swift. In Swift, we have a lot of different cool types. And also, I guess it's also technically not true in Java. They have interfaces as well, right? So they have a version of protocols, right? But that's kind of what UML was made for. I don't know the full history of UML, so I could be wrong. Maybe it was made for Perl or something like that. I don't know. But it's primarily used by Java folks. In it, you basically take all of the types that you have in your code and you break them down into boxes. And within the box of types, you have two segments. The top segment within the box are your properties. They're your type properties, okay? And there's fun little symbols, like you can have a plus or a minus. They have the name and the type of the property, right? And then they'll have arrows if those properties point to other types, okay? And then beneath that, you have functions, okay? And those are all the different, or methods, if you will. These are the functions that you add to your types, right? And sometimes those call or use or return other types, okay? Now, sometimes you'll see these annotated in a particular way. Here, you'll notice that there's this +1 ... star thing and a +1 on the other side. Can anyone guess what these things mean on this UML diagram? The +1 and the +1 ... star. Anyone? Yeah, cardinality, right? Like relationships, right? Yeah. So we'll recall from Swift data, we talked about relationships between types, one-to-one, one-to-many, and many-to-many. That's what these things mean, okay? You can learn to recognize them over time as you see more and more various versions of someone trying to express that same concept, right? Although here we have, this is fun, this is a 0-to-many, which is a very different kind of thing, right? That's a nullable 1-to-many type, but don't worry about it. Anyway, so this is a UML diagram that's also acting simultaneously as an object relationship diagram, which object relationship diagrams, we did look at them with the ORM stuff. They are a form of UML. They're like a more specific form, right? But at the end of the day, the point of a UML diagram is to show you how your different types in code all interact with each other, how they call each other, how they own each other, and doing this gives you a kind of top level view, like a chessboard, and all the chess pieces are your different pieces of code, and you can see how they interact. Oh, look, this knight is L shape away from the bishop. I don't know the numbers and letters, guys. I'm sorry, I'm really bad at chess. Like E4, whatever. So that's UML. Okay, UML diagrams. They're kind of old school. They can still be useful, even though they're sort of old school. Again, as I mentioned, there are very strict forms of UML diagrams. When you are writing on the whiteboard with your colleagues at work, you will almost never follow strict UML. You'll do a form of this that doesn't have properties or functions, or only has the properties and functions that you're currently talking about when you're writing. Most of the time, when you're sharing information with someone at work and you're drawing diagrams, if you go back and look at that diagram later, it makes no goddamn sense because it is not accompanied by your explanation as you draw it, okay? Arrows have different meanings when you're drawing them live and explaining what they are. Oh, this one means it owns this, and this one means it calls this, but you're not denoting that differently because whoever is watching it knows what you're talking about. They remember, right? So again, you won't exactly see something precisely as segmented and strict and once again, went to sleep. We think we fixed it. We'll see. So that was UML. Next up is sequence diagrams. Sequence diagrams they're for a very, very specific use case. Occasionally, a UML diagram gets really, really complicated looking with a lot of arrows pointing in a lot of places because you have a lot of types calling each other. And it's complicated too because you'll have to start putting little numbers where you're like, okay, so this function calls this function first. This arrow gets a 1, and this one calls this one next afterwards, which gets a 2, and then this one calls this one, which gets a 3, right? And it gets really complicated. Sometimes it's easiest to express an idea or a concept that you're trying to share with someone in terms of programming with a sequence diagram. A sequence diagram is for complicated calls and callbacks that have to occur in particular orders, okay? So if you have a particular sequence of events that are occurring in your code, and it's complicated how those events relate to each other and to the types and the life cycles of those types, right? Whether or not they are still in memory or not, right? Then you use a sequence diagram to express that. So for example, here, you can see that the game type, all right, calls the deck of cards type using the shuffle function, right? And then it'll call it with the game cards function, right? Then it passes to the player, take cards and bet. And honestly, I grabbed this randomly, and this is a shitty sequence diagram. I'm sorry. So I don't, there's a really good one on Wikipedia, but when I tried to grab it in, it doesn't have a background color, so it was completely invisible on this black background. I should have made it white. I didn't have time. Sorry. I just thought I'd just grab another one. This one kind of sucks though. So if you go to Wikipedia sequence diagrams, they have a really great example there of email and how an email client interacts with a server, and it makes server calls, right? When the email client first opens, it will make a server call and it will say, oh, send any email that I was planning on sending that wasn't sent, right? And then it'll be like, oh, cool, send a new email when the user sends it. And then you get a message back. And it's like, oh, cool, hey, we sent it, right? And, so on and so forth, okay? So it's really about how different types interact with each other over time, right? It adds a dimension of time. And the way that you read it is from left to right, top to bottom, okay? So the events come in, and then you go down along, or sorry, I guess it's top to bottom, left to right. So you go down along the life cycle of whatever it is until you hit an arrow, and then you follow that arrow over to the new type and its life cycle, and then you'll go down and you'll follow its arrow, and then if there's a call back, you'll go back that way, and then so on and so forth, okay? So that's what a sequence diagram is. I'm sorry, this is a terrible example of one. Okay. And now this doesn't work. Whatever, there's only one more slide. Where's the mouse? Hello? Okay, now it works. Cool. All right, last is a flow diagram. A flow diagram is similar to a sequence diagram in that it is intended to capture the concept of time, but sequence diagrams are intended to capture time in more of a, this, that, the other thing, and properly showing you how asynchronicity and callbacks can work. Flow diagrams are more about logic over time and how your logic bifurcates and splits and your program's control flow happens, right? So typically with a flow diagram, you will talk about the things that you do in your code with rectangles, and then you'll talk about decisions, or sorry, not decisions, but questions that you ask in your code, usually Boolean questions, right, that resolve to true or false, and those are done with diamonds. And then out of the diamonds come 2 arrows, one for if it's a false and one for if it's a true. And that shows how your control flow changes based on how things go, right? And with this, you can express some pretty complex concepts for how control flow exists in a very elegant, visible way. And also then you can show how different results are likely to happen. And if you set these up, like there's some tools you can set up with this where you can actually like feed it information, like give it a piece, give it a set of states, and it can actually like show you step by step the control flow. So it'll go like boop, and then it'll highlight boop, and then it'll do the next, and then it'll like based on whatever state you set, it'll go to the correct thing on a conditional, right? On a conditional block. So there's some cool tools for that. You don't necessarily need them for flow diagrams to be helpful. Yeah. And then last, of course, when I say last, of course, I mean, I don't have a slide for this because it's kind of weird, but basically you will get hybrid versions of this, of all three of these things all together in one diagram where someone's just drawing it in front of you, and they'll be like, oh yeah, okay, so so we have our like hiking trails, right? And it's handled by the hiking manager, right? And the hiking manager calls the hiking service, right? And then the hiking service, okay, then the hiking service has to make an asynchronous call over to the National Park Service, right? And then the National Park Service, it only exists. It's an AWS Lambda, so it only exists while it's being called, right? And so it actually makes a quick call over to the database, right? Which is like it's like the Smokey the Bear database. That's what we call it because we're funny and we like the national parks, right? So it's the Smokey Bear database, right? And then that'll call back. It'll give it. It'll return back with the data, right? And then here's the data. That's what it comes back with, right? It comes back with our data, right? And then it comes over here like this, right? And then now our services, that will then call back over the network, right? And you see what I'm saying? Okay. This all makes sense, kind of, when I'm doing it to you live. But if you look at this diagram now, you're like, what the fuck is this thing saying, right? So you'll see that a lot. Yeah, not super, useful, but for storing documentation long term, but it can be very helpful for communicating with someone in the immediate term. Okay, so now we're going to look at compiled documentation. This is where we're diving back into Xcode, friends. So let's go ahead and do that. Let's sit on my chair. Whoop. There we go. Close this. Pull up Xcode. Here we go. Okay, so Xcode has added a cool new way to generate documentation that is fun to use and family friendly, all right? The way that you can do cool documentation in Xcode involves something called docc, or doc compiler, documentation compiler. When you use docc to create documentation, what you end up with is documentation that looks a lot like what Apple creates in their documentation, okay? Excuse me. So it looks very nice, and it's cool, right? So let's go ahead and take a look. Let me find a nice, juicy, complicated file here in my package. Yeah, this will do. Okay, cool. So here's this is my Amiibo client, okay? So this is the thing interacting with the network, the Amiibo API. This is my version of the final project, guys. I made sure to do 1 too, so that I knew what I was putting you through, okay? I did not share it though, because I also want you to like write the code yourself. I'm not gonna, don't copy my project, all right? Obviously you can look at this now. I'm assuming you're all already hitting your endpoints just fine. We're close enough to the end. Let me actually make this a little bigger. Here we go. Okay, so here we've got our class, all this stuff, right? You can add comments to your code, as you know, with // So you'll often, in code, you'll see stuff like where you'll see something like, oh, cool, this is, this function hits the API / last updated endpoint and then does some stuff, right? Cool. So you'll add comments like this to your code all the time. And if you put it in front of functions, that's usually intended to be something about the function, right? Now, when you are going to use this function elsewhere in the code, or if you've used the function elsewhere in the code and you want to remember what it does, you know, let me see if I can find it elsewhere actually real quick. Yeah, here. Okay. Close this. Close this. Here it is, right? So let's say we've got this here and we don't remember exactly what this function does, right? So you can hold down command, you get a little finger guy here, you know, a little clicky, right? You click on that, it'll take you to the code, okay? Now, if you want to do this for a function that you have not written, right? Or a class or a type that you have not written, like JSON decoder, you can, right? But what it takes you to isn't exactly code. This is more the public interface, okay? So it just shows you the information that's available to you through autocomplete, right? The things that you get when you type it and you hit dot, right? You don't actually see any code here, right? They have this custom function, but there's nothing here. So in a lot of ways, it looks like a protocol, even though it's an enum. Or sorry, not an enum, it's a class, right? Now, when we click on this, we could go here, right, and see that, and you know, that's fine. But there's another thing you can do. If you instead hold down option, you get a little question mark, right? When you have option, you click a question mark, you get this, okay? And this looks suspiciously like the text on Apple's documentation for JSON decoder on their, you know, docs website, the one that I've allowed you to use for quizzes, right? And that's pretty cool, right? So how do they do that? Well, it's actually pretty easy to see. If you click into this, you can see how they do it. They do it with, oop, it's going away. Come back, come back, come back. No, there we go. Okay. They do it with comments. It's pretty nice. You can just do it with comments, okay? So all you have to do is comment things in the correct format, and all of a sudden, you have documentation that looks nice, and it's formatted like Apple's documentation. Now, note that they have special comments here. They have a triple comment, okay, rather than your standard double. So right now, for example, if we click Option Get Last Update here, this is all we see, okay? But if we make this a triple comment and we click Option Get Last Update, all of a sudden our text is here. And we'll be able to see that little note that we left ourselves elsewhere. Now, the first line that you put is kind of a high-level summary and it gets bolded and stuff. So down here you can put like details about my code and what it does and also llamas, right? And now that you've done that, you can click Option Click, and you can see down here, it moves those into a discussion section, right? And you can also do some fun things in here with markdown style formatting. So if you do triple backtick, like so, on either side, okay? And then in here, you say, you know, let results equals get last update. Sorry, and try await, get last update, right? You know, and you say Swift here like this, and then here you can add a little thing where it's like, this is how it gets used, right? Or this is how you call it, I guess, how you call it. And that's not actually true because it's static. So this would actually be Amiibo client dot get last update, right? So this is, you know, this is cool. You can then hit Option Click, and you can see you get a code block here, right? And so you can actually provide example code for how to use your code for yourself in the future if you ever need it, very quickly and very simply in your code. You can also, as a developer, you can look at this and read it and not have to Option Click to get the nice formatting, right? It's, you know, you can understand what's happening here, right? Cool. Okay, so you can do that. Other things you can do, kind of cool. So here, this one takes in a parameter, right? What you can do if you're feeling a little lazy, right? Feeling cute, might delete later, right? You can click Add Documentation here, and it actually creates stubs for you to fill out. So now you can provide information here where you say, oh, okay, so this function gets all Amiibo from the particular type of endpoint that is passed into it, right? And then here you get this parameter endpoint and you give a description for that parameter, right? So this is the type of endpoint we want amiibos from, right? And then here in returns, we can just say returns amiibo entry keys to be fetched from later, right? Which is, how it works, okay? And so now that we've got all that, we can option click, and we can see here's our initial description, and then we have these parameters, and here's a breakdown of parameters and our return value. And again, this looks exactly like it does, or it would, on Apple's documentation for their stuff. They add a little bit more detail than I just did, but that's okay, right? If you want to take this documentation and package it up rather than have it only be available when you option click on the function or a call to the function, you can go to product build documentation, okay? And when you do this, even if you have not provided any doccc style comments, docc style comments, you still get a bunch of information, okay? So here, our Amiibo client project now has all of this stuff, okay? So we know that I only have one class in the Amiibo client. It's the favorite class, okay? And we have this one protocol. And then we have a bunch of different structs and then one enumeration, right? And then these are the modules that I'm using, right? Where there's more, data and information on them, right? And then they also have all of their stuff over here as well under app frameworks, right? And you can click on like class favorite and you can see all the stuff in it, right? Like Amiibo series here, right? And, oh, cool, this is inherited. I didn't write that as a comment anywhere, right? That's automatically added by docc, okay? But that's useful context and information, right? So you get all this stuff, including like these default implementations and stuff, right? And their relationships to other objects, right? Oh, this particular favorite type conforms to all of these protocols, right? So useful to know sometimes to understand what capabilities a particular type has when you don't want to go and find all of the extensions that are adding protocols to it, okay? You can also do, there's like a way to do this on the command line where you can generate it as a website and then you can host it to a static website URL like GitHub Pages. And then you can actually have your documentation be publicly available. And you can include that as a part of a library or something. If you're creating a library for other people to use, you can make a part of your build process, a part of your CI/CD pipeline, if you will. One of the steps is to compile your documentation into a website and then SSH into and host and post it to your, web hosting site so that it updates the website whenever you push new changes to the code. Okay, pretty cool. But primarily for your purposes, just doing the build documentation button here is pretty nice. So that's documentation. That's docc. Are there any questions about documentation and docc in Xcode? Cool. All right. So one thing I wanted to talk about before we go was a breakdown kind of the different questions that you're going to have in your final exam. So let me get a little text thing open and I will, okay, I just want to have a new empty text file, Xcode. This shouldn't be hard. Why are we making it difficult? Just give me a new one. Thank you. I'm not going to save it or anything. It's just here. Okay. So the exam will be roughly 25 questions, okay? For the, one half of the exam is going to be on what I call core Swift. So that's just basic understanding of Swift. Topics for core Swift include, let's say 50%. Optionals, functions and closures, types, and types includes enums, structs, classes, protocols, there we go, spell it right, generics. And then lastly, concurrency. And by this is, I mean async await, not dispatch queue. So 50% of the test will be on, sorry, I say 50, it's more like 40%, roughly, right? Let's call it 10 questions. Okay. Then there will be a bunch of questions on Apple libraries. That's the next section. That's what I'm calling the next section, right? That was the kind of second half of the class, right? So there's networking, and I will say 10 questions. Okay, so there's networking, there's UIKit. I will say just one question. We didn't spend a lot of time on UIKit, so it's just the one. Swift UI, Swift data, and Swift testing, okay? So these are the Apple libraries. These are the ones, this is where 10 questions are going to be, the next 10 questions. And then there will also be a section on professionalism, which I've talked about throughout the class and I talked a lot about today. So there's going to be some questions from today. So along with some of the stuff from today, and that will be included, semantic versioning, there will be a question on that, at least. And there will be like 5 questions here. Whoop. Whoop, like so. Okay. And then let's see, access control. CI/CD. Specifically, its place in mobile, how we use it. Feature flags. And dependency hell/graphs. Okay? So this is, dependency graphs, dependency chain, right? Just, I'm just going to call it dependencies. Basically, how you set up SPM dependencies and stuff. So this covers not only stuff we talked about today, but also stuff that we've gone over throughout the class thus far that falls under the same category. It's not quite core Swift. It's not quite an Apple library. It's just more general programming. How do you comport yourself as a programmer? How do you build stuff? Okay, any questions about this breakdown for the final exam? We're targeting it to be about 2.5 hours. So it shouldn't take the whole class, but you have the whole class to do it, okay? So if you need extra time, you should have a whole hour extra. So, and if you finish early, you can just leave. And we'll go over that all more during the review next week. So are there any questions about this breakdown, though, before I let you all go? Multiple choice. Yeah. Yeah, they'll be multiple choice or like true and false. Yeah. I know I got cute in some of the quizzes with like ordering questions, right? Like to try and, like fake having you write code without having it like be free text writing code, because that's just an awful experience in Canvas. But or like the things where you had to categorize stuff or like pick from a drop down, right, for stuff. I'm not going to have any of that. The final is going to be multiple choice and true or false, and that's it. So yes, you will have access to all the same stuff that you had access to for all the quizzes. Yep. Access to all docs that quizzes did. And then what was the other thing I was just saying? Oh, multiple choice or true/false. This is my promise to you right here. So this is what the final will be. Cool. And then so study this stuff throughout the next couple weeks. Come next week with questions if there's anything that you're not sure about. There was something on a quiz that kind of you stumbled on a little bit, or there's just things when you're reviewing, you're like, oh wait, this doesn't make sense. He said this, what does this mean? And you can come in and you can catch me in saying something wrong in one of my old videos or something, right? Or one of my old lectures. So, and then I'll be like, oh no, yeah, that guy's an idiot. I don't know why he said that. That was 3 weeks ago, Dan. He's different, it's not me. Cool. Okay. All right. Well, I'm going to let you go. Yeah, I will see you all next week. I look forward to reviewing your code for your projects this weekend. This will be my last kind of review of your code. So it'll be the last feedback I give you before I grade it. And I will be grading whatever you have posted to the GitHub by noon on Friday of next week. Noon Friday next week. So don't be planning on working on it in the exam review, because anything you do in the exam review and you post to your GitHub later, I will not look at. I'm going to pick the last commit before noon Friday next week, and that's the due time for the final project. Cool beans. All right. Have a good weekend. I'll see you all next week. I should save this actually. Send it out. Oh, I should stop recording.